In the previous lecture, we learned that offshoring and cost savings are not correlating always, and that cost savings in offshoring software development are context dependent. In this video, I would like to share a real-life project experience, the result of a case which is in the context that was pointed out as problematic for cost savings, which is large-scale distributed software development. This software is complex and it's a legacy system, which means that there are millions of lines of code to maintain and enhance, and also which means that to be productive in such a system, it might take more than 5 years for a developer onboarded late in a development process. So let's look into what happens when such organizations scale up in an offshore site. And the questions here are whether offshoring leads to significant cost savings in such a context, and what are the known impacts of offshoring complex software development. And also, so in particular, looking into hidden cost factors. So the project that we will talk about today is a very highly distributed project, which in the beginning was initiated in just one location, which was Sweden. And from the slide you can see that all the sites included in the product development are affiliated with Sweatco. This is because Sweatco owns subsidiaries all around the world. And they scale up in different locations for two reasons. The first reason is that in Sweden, it's quite difficult to get an allowance to employ people locally because of the salary-based differences. And the second reason was to make adaptations for the local markets, which, if you remember, is the good reason to start offshoring. So here you see the satellite sites in US, in Italy, Poland, Turkey, India, and China. And in the calculations that I will share with you, we will talk primarily about India. The Indian site was onboarded in this complex product 2 years prior to our investigation, and we could get quite a rich amount of data for this site, and that's why we have selected it. And we will compare them to more mature sites, which are Italy, US, and of course Sweden, the main location of the development at the moment. So to start with, our point of reference is the salary-based cost comparison. So we had 400 galleons per hour in Sweden, and we use galleons as a fictitious currency because we were not allowed to share the cost in euros or Swedish crowns. And in comparison with the Swedes, 1 hour of development in India costed 100 galleons, which means that the difference is 4 times. Sounds like a really good business case, doesn't it? Well, let's make one step forward. What we call a resulting hourly rate is a salary-based hourly cost and an extra cost per hour when looking into things like extra documentation, travel, knowledge transfer, and so on. So we talked to the people and looked into different calculations that were available at the company, and we gathered information about cost of process documentation to maintain the development on a distance, administration cost like human resource people administering the traveling and the visa operations, cost of quality control, rescue cost, extra hardware cost, planning overhead, and also managerial overhead. But in comparison with these other costs, as you see here, the top 3 costs were knowledge transfer cost, travel and relocation, and mentoring and support. And these 3 costs were actually very significant in the beginning of the collaboration, in the first and a little bit in the second year. And these all costs are expected to go down in the future. So when we add this to the hourly rate of 100 gallons in India in year first, we have 375 gallons per hour, or more than 3.5 times higher cost per hour in India in year 1, and 161 gallons per hour in India in year 2. Well, let's talk about inefficiency, indirect costs. We learned that Swedish developers and developers from Italy and US, the mature teams in those locations, are much more productive than the new developers. And this is really nothing surprising, because if you even onboard a team in Sweden, in the beginning, these developers will be less productive than their mature, experienced peers in the same location. However, India was perhaps a specific location to look at because of high attrition rates and because of the distance between the main site and the secondary site. So we had calculated the bottom line cost per 100 complexity points, or the cost for something produced by the developers as a resulting hourly cost, salary-based cost and extra cost, divided by the number of, or the productivity, the number of complexity points per 1,000 of hours. So what you see here are the productivity differences. The mature teams in Sweden are the benchmarked teams. They have 100% of productivity. In relation to that, immature teams are 3.7 times less productive. And this makes a huge difference when you consider that the time the new team spent on learning and training is not something the company is willing to pay for. If you only divide your cost by the productive hours, then the result looks like this. If you have a given productivity of mature teams, 99.12 complexity point per 1,000 of hours, and the Indian teams in year 1 and year 2, 25 and 24 complexity points per 1,000 of hours respectively, then your bottom line cost look as follows: 44 in Sweden versus 141 in year 1, or 66 in year 2 gallons per hour in India. So this already shows that Swedish teams, and don't forget we compare productive teams and new teams, they are still after 2 years more cost efficient than the Indian teams, even considering that the salary-based cost difference were 4 times different. So performance differences are not surprising and actually not related to offshoring at all. As I said, if onboarded in a legacy system, any developer would struggle in the beginning. However, what we saw that the productivity in year 2 was actually lower than the productivity in year 1. The desirable learning curve, of course, companies want accelerated productivity. The more realistic or expected learning curve is an S-shaped learning curve. When you struggle a lot in the beginning, then you have a steep learning, and then to become fully productive, you still have some catch-up gaps to catch up with. However, the learning curve that was evident in the first 2 years was really unexpected because there was lack of improvement. And the reason behind it is high attrition. If you look into the amount of green people, so green columns are the new developers employed in the given period of time. The gray ones are existing developers from the previous period of time, and the red ones are the developers who left. Then you see that in order to employ a certain number of people, after 2 years, the company has lost approximately the same number of people. So it's almost 100% attrition in 2 years, which is very alarming. And one more analysis that we did is to look into the experience level. So over time, people are expected to become more productive. So let's look into how many people have 12 years of experience, how many people have 6 months and lower than 12 months of experience, and below 6 months of experience. So you expect that after 1 year, your teams will have 12 months of experience, don't you? But look at this. The amount of people with 12 months of experience over time is decreasing after the first year, which is another very alarming signal, and also the reason that explains the lack of improvement of the productivity. Now, the actual data suggests that the productivity between the 0.0 and 0.2 went a little bit down. We have modeled different scenarios. One scenario in which the productivity goes in 5 years, catches up with the original developers. Another that it doesn't change for 1 year, but goes to approximately 75% of the original or mature team productivity. And the third and fourth scenarios that it will not change much. It will remain the same, 25% of the productivity or 50% after 5 years. And what we suggest here is that judging from the costs and also from the actual productivity data, the likely scenario in which this company will break even after 5 years is scenario 3. However, it's unlikely, given the actual data of the productivity, that this will actually happen. So our conclusion basically for this company was that it is likely that Indian site will not be cost efficient in the future. And if this development is placed there to scale up and to get more people, then the company should find the strategies to keep the people in the company and in the development positions. And therefore, this is the only way to break even in the future. So, what are the conclusions here? The first conclusion is that attrition is a huge problem. However, having said that, I think that offshoring doesn't need to be a failure, because India might be very special because of this promotion-seeking behavior and people changing their jobs frequently. But last but not least, long learning curves together with attrition is clearly a deadly combination.